Hey everyone, my name is Tony Bourke. I make my living as an instructor. Typically I teach networking topics and sometimes server and storage topics, and I'm also a skydiving instructor. That part is actually real. But today I want to talk to you about software-defined networking. Specifically, is it still a thing? Was it ever a thing? And should I care? So I've seen this come up a couple of times in Reddit. I saw a Reddit post recently. So this is recorded at about mid-May of 2020, and it talked about them not getting SDN, what's the big deal and whatnot. And it's a good question, and it's certainly a fair question, and I think it's something that might be worth discussing, so I'm going to put together this quick video here. Maybe not quick, but I'm not going to put a whole lot of editing into this. So I'm trying this out as a new format for conveying some information using whiteboard application and the camera and mixing them together and seeing what happens. So let's get started. So SDN, software-defined networking. Is it a thing? Was it ever a thing? Again, a good question. There's a lot of hype surrounding it. People have thought maybe it's just a bunch of hype. It's all marketing. It's just the same old products that's been regurgitated with a new SDN label on it. And this very same cycle happened with the term cloud computing. So if you remember back, I think it was about 2008 or 2009, Larry Ellison was at some sort of big shot conference, and he was freaking out about the term cloud computing. And he said, and I quote, "It's just a computer attached to a network. What are you talking about?" And basically lambasting the term cloud computing, and it's not any different than anything that we've done before. And in many regards, he did have a point. However, about 2 years later, he was on stage at Oracle World or whatever conference they have, announcing the new Oracle Cloud Platform. So clearly, he's had a change of heart. And I think part of what, and SDN has certainly undergone that kind of same thing. So if you take SDN hype, and we draw a graph here, we have hype on this axis, and then we have time on this axis. Probably about 5 years ago, or maybe even a little bit longer, there was certainly an uptick on the hype of SDN, and it has kind of gone down. Now we've got SD-WAN and some other stuff that are kind of stealing the spotlight. So was SDN worth the hype? Was it purely marketing and whatnot? And well, I think we can get some insights to the term cloud computing. Like I mentioned before, Larry Ellison had that freak out. And cloud computing is a term that went through a similar hype cycle, and we can learn a lot from it. So number one, there were certainly products that were the same thing as they were before, and they threw the word cloud on it, and all of a sudden some crappy product was all of a sudden good. And I've seen that actually happen. I was at an event where a vendor presented a really crappy product, and they put the word cloud in front of it. It had nothing to do with cloud, and didn't make it any less crappy. But cloud computing, there is a difference between cloud computing and what we've been doing before, and the term itself, instead of being kind of a nebulous term where it was unclear of what cloud computing was, NIST, the National Institute of Standards and Technology, came up with a definition of cloud. They defined a couple of different types of cloud: public cloud, private cloud, community cloud, hybrid cloud, etc. But they also came up with 5 characteristics that you have to be considered a cloud platform. And this is a good demarcation point between traditional computing and cloud computing. So number one, for it to be considered a cloud computing platform, either public, private, whatever, is it had to be self-service. Now compare and contrast traditional IT in the enterprise with something like Amazon Web Services. Amazon Web Services is a cloud computing platform. It's kind of the definitive one, but there's also Azure and Google Compute Platform and some others. But and everything there is self-service. If you want a VM, if you want some storage, if you want some block storage, or if you want some object storage or whatever, you swipe your credit card, it's on file, and then boom, you can get those resources. You're going to pay for them, but you're going to get them. Contrast that with most enterprise IT, and typically things are done by hand. If you're a consumer of these resources, VMs, storage, network ports, whatever, security rules, etc., then you typically will open up a ticket, some sort of service ticket. It goes into a service queue and then gets worked by the people. I've been on both sides of that. I've been the person that has requested the resources, and I've been the person that was providing those resources by going through the ticketing system. So that can't work with a cloud computing platform. A cloud computing platform has to be self-service. Now I will get to why this is related to SDN because they are related, but for now we're just talking about cloud computing. Number 2 is APIs. So some sort of universal method for automatic configuration of these resources. Now AWS has a command line interface that you can use. It has a GUI that you can use as well, but there's also a REST API that you can use and some other automation tools like Terraform and so forth that you can use to instantiate whatever resources you want. And you don't have to do it by hand. You can just run a script or run a YAML file or some sort of declarative language, and it will go and will make what you designed happen on their infrastructure. Same thing with the other cloud providers as well. So it has to have an API. In the networking world, we haven't had APIs before. We haven't had them for a very long time. We have them mostly now, but there's some exceptions. But before that, we really didn't have a good way to do any kind of automation. We lacked the automation tools. We either had SNMP, which is not a very good tool for that purpose, or we did something like screen scraping, where we ran expect scripts or something that would pretend to be an interactive user on the command line. They weren't as reliable or robust, and they caused some problems, but APIs allow for a program to talk to a system and to do automation. So you have to have that to be a cloud computing platform. Number 3 is multi-tenancy. So some of us are old enough to remember the Cola Wars, and multi-tenancy, I like to give the example that we should be able to put Coke and Pepsi onto the same platform and not have them mess with each other, not have them cause any problems with each other, either deliberately or accidentally. So we have to have some sort of multi-tenancy. We don't tend to think about multi-tenancy as being a thing in the world of the enterprise, data center, etc. But it can be, and I'll tell you why in a minute. Number 4 is elastic. So this is an environment that's always in motion. So think about Amazon Web Services, or think about the consumers of these services like Netflix, Twitter, Facebook. They're always, whether or not they're running on their own platform or they're running on someone else's platform, they're constantly spinning up and spinning down containers, virtual machines, storage, etc. It's a very dynamic environment. Whereas most of us in the data center, or most of us in enterprise networking in general, we're used to a much more static environment. And we're used to a low rate of change instead of a high rate of change. So it has to be an environment that supports a high rate of change. It doesn't necessarily mean we have to do a high rate of change, but it must be an environment that supports a high rate of change. Quickly spinning up and spinning down resources, configurations, and even done in the middle of the day. And then number 5 is metered service, because some of us may have spun up some resources on Amazon, played around, and then forgot about it. And at the end of the month, we got that bill. A lot of companies have found this to be the case, and you get that large bill at the end of the month. So of course, they're charging for these services. And not to say that they shouldn't, but they do. And so what does that have to do with software-defined networking? Well, unlike cloud computing, there's no one has swept in like NIST did from the U.S. Department of Commerce. So no one swept in like NIST did to say, hey, this is what software-defined networking is. This is what software-defined networking is. But there are a couple of things that most vendors and most people in the industry who work in these technologies, that they will find this to be a couple of things that they find to be true, or a couple of characteristics that they find that they typically all will have. So number 1 is a controller. And at least in the data center world, we really haven't dealt much with controllers. We've had a couple of attempts over the years, but nothing has really stuck until recently in terms of having a centralized network controller. And but software-defined networking platforms typically will all have some sort of centralized controller. It acts as a central point of truth, so you do the configuration on the controller instead of the devices themselves. And it also acts as an orchestration platform. So if I have something that requires a network service, like a VLAN or a port or something, then that orchestrator can talk to the network controller to get those resources, or inquire about resources, or inquire about something, rather than hitting 20 individual switches. So that's an important part about SDN, is it provides a controller, a single point of truth, and an orchestration point. Single orchestration point, which is important, and I'll talk about that in a minute. Number 2 is, of course, APIs. So you have to be able to connect to that controller via some sort of API. Typically, It's a REST API, but it doesn't necessarily need to be. Just some sort of automatic way, some sort of programmatic way to interact with the system. That's not the command line, that's not the GUI. Now, they can have command lines and they can have GUIs, and they usually do. Cisco ACI, Big Switch, which is now part of Arista, they all have command lines, they all have GUIs, and they all have APIs. And generally speaking, the API should be able to do everything that you can do on the command line or in the GUI in order to be considered a true API, although there's probably some exceptions there. So we've got that API in there so that we can programmatically interact with the system. And that's not as important for humans, and it's not even as important for our scripts as network administrators if we're writing some automation scripts. But it's more important for an orchestration system to talk to another orchestration system. So, for example, vCenter needs a resource that talks to the network controller via an API. We'll get to that in just in a little bit. And then finally, number 3 is some sort of network virtualization. It usually means VXLAN, but not always. There are some SDN products that don't use a VXLAN at all. For example, Big Switch doesn't use VXLAN. They just use traditional VLANs. But the things that this network virtualization is some sort of abstraction layer, which is what Big Switch does provide, is it gives us kind of 2 of the things that we talked about in cloud computing. One of them is multi-tenancy, whether or not we call it multi-tenancy or not. And it also gives us an elastic environment. An environment that can take a lot of change, although part of that has to do with the API as well. So why are all of these things important to us? I mean, they're clearly important to cloud computing. Being able to be self-service. I mean, can you imagine AWS running where every time you ask for a VM to be spun up, someone had to go spin one up in a hypervisor? It would be slow, it wouldn't scale very well, and the cost would go way up. Has to be an API, otherwise we can't programmatically instantiate, de-instantiate these resources, all the scripts wouldn't work, and we'd be going back to screen scraping and other things, so it'd be a nightmare. Multi-tenancy, of course, Microsoft Azure needs multi-tenancy. Elastic, being able to make all these changes in the middle of the day. So imagine how many state changes that Amazon or Google Compute Platform or Microsoft Azure or any of these cloud providers, imagine all the different state changes in terms of VMs being spun up, networks being torn down, that go on all throughout the day. I mean, they do maintenance windows for certain tasks, but most of the time their environment is in a consistent state of churn. It's never the same from 1 millisecond to the next, probably. And then metered service, we're gonna skip that mostly. So why are all these things important to us as network administrators? Well, let's talk about the controller first. I think the controller is one of the most important parts about the SDN story, and one of the most important parts about moving from how we've been doing things in networking now to moving things to how we will in the future. The controller provides a couple of things. One is a single point of truth. So all the configuration is done on the controller, and then the controller then goes out to the individual devices and then configures them. And then if I want to query the system, if I want to say, hey, you know, have I used VLAN 10? I can go to one place. I don't have to query 20 different switches. I don't even have to know that there are 20 different switches or 40 different switches. I don't have to know about the details of the minutia of what's going on in the network. I just go to one place and say, hey, is VLAN 10 available? You know, that's just one example of many different types, which also goes into orchestration. So controllers provide a point of orchestration, which is important as we do more and more automation in the data center. The hyperscalers have been doing this since they were hyperscalers. You can't get to hyperscaling without doing this. So let's talk about an example of what orchestration, what it does. So I'm not going to use any specific vendors on the networking side because there's a couple of different vendors that have SDN solutions that provide this capability. But I will talk about a specific vendor on the compute side. So we're going to talk about Vmware, because they are fairly universal. Most of us in the networking world have at least interacted with VMware casually. I work with it all the time because I'm an instructor and I'm dealing with labs, and most of our labs are on the VMware platform. And most of our clients, the ones that I do consulting with, have all run VMware. There's a couple of exceptions, but for the most part, everyone's got at least VMware, and maybe they have VMware and something else. So let's talk about what VMware has. VMware does have a controller, and VMware has had a controller for a long time. So Vmware Vsphere is the umbrella term for their hypervisor suite, and they have vCenter. That is their controller. That is where you do your configuration. Now you can configure the hypervisors, the ESXi hosts by themselves, but for the most part, when you're doing VMware in the enterprise, you're doing VMware in production, or even most labs, you have vCenter as the controller. It handles the resources, the allocations, all the configuration is done on the vCenter controller. The state is kept on the vCenter controller. It's the single point of truth. If you want to know anything, you typically will go to the vCenter controller. If the vCenter controller doesn't know it, it will go to the hypervisor to get it for you. So that's where we typically interact with. And then it also has, the hypervisors. And it has two units of, two of the units that we typically deal with, the PDUs, the lowest common denominator, are the VMs, the virtual machines, and on the network, that's on the compute side. But VMware Vsphere also has a pretty big network component as well, because we need these VMs rather, to be able to contact each other, and they also could do containers too. And they need some sort of communication. So on the compute side, we have VMs, and on the networking side, what we're dealing with is typically port groups and virtual switches. But we're going to talk about port groups. So if you're not familiar with what VMware does, or with how VMware networking works, I'll go over it real quick here. I've got a hypervisor. So this is, we call it ESXi, or vSphere hypervisor. I think that's the term they like to use now. And I've got, let's say I've got 3 virtual machines running in this hypervisor. It's all in one system. So VM1, VM2, VM3. They're all going to have vNICs. So these are virtualized NICs. From the operating perspective, it thinks it's got a real NIC, but of course it's not real. Every hypervisor will have at least one virtual switch. So one vSwitch. It could be a distributed virtual switch, or it could be a standard virtual switch, depending on what license and how much money you're willing to pay. Most of the time I'm dealing with the distributed virtual switches, but for the purposes of this discussion, doesn't matter between them. And by the way, I'm not going to talk about NSX. That's a little bit of a different of a beast. But most people are interacting with this type of VMware, so without NSX. And then we have our port groups. So port group 1 and port group 2. Now, if I'm going to plug my vNIC, so there's a drop-down menu. So when you spin up a VM or you're configuring a VM, it says, okay, I've got my vNIC. What port group do you want to attach it to? So it gets a virtual port on the virtual port group. And then if your VM wants to have connectivity at all, it must be connected at least to one port group. Now, that maybe needs some other things too, but at least it has to have that. Now, the communication by default between VM 2 and 3 only requires layer 2 adjacency. As long as they have IP addresses on the same subnet, there's nothing to prevent them from talking to each other, and they can talk to each other. Between 1 and 2, however, I can't communicate between them because the port groups don't have anything connected to each other. So they are separate layer 2 domains. Now, you're probably thinking to yourself, if you're not familiar with what port groups do, you're probably thinking at this point, well, this looks a lot like VLANs. And for the purposes of this discussion, and for all intents and purposes, a port group is equivalent in almost every way to a VLAN. So at least for this discussion, we can think of it as being equivalent to a VLAN, and that's pretty much what it is. So if I want port group 1 to be able to talk to port group 2, what do you need from one VLAN to talk to another VLAN? We need a default gateway. VMware doesn't provide one unless you put it in a VM. So typically we have the default gateway on the switch or a router connected to them. So now we need to get these packets. And either way, we still need to get these packets that are generated by these VMs. We need to be able to get them out of the hypervisor and have packets come into the hypervisor, because of course we need some sort of network connectivity. So to do that, we have on the hypervisor, we'll have one or more what are called VM NICs. VMNIC 1, VMNIC 0. And they are connected up into some switches. Doesn't matter who. Now, if I have two port groups, I'm going to need a way to convey the traffic up the interface to the switches so that they're still separated. And you think, okay, well, this sounds like a pretty good job for VLAN, so and 802.1q tagging, and that's precisely what we do. Port groups are almost always assigned a VLAN. Do pink here. So this is VLAN, so port group 2 will be VLAN 20, and port group 1 will be VLAN 10. So you're probably familiar with this. I just wanted to go over it really quickly. Now, this requires some sort of coordination with your virtualization team, or your networking team, so they have to talk. And this is typically done by hand. If I create a new port group, that means I need to talk to my network administrator and say, hey, I need a VLAN. And the network administrator goes into their documentation. They check the switches. Oh, I think VLAN 10 is available. Maybe they might even have a script that goes through and checks the VLANs that are configured on each switch. And to make sure that VLAN 10 is available, and then they'll go through one by one on each interface and configure VLAN add VLAN 10. Or switch port, trunk, allowed VLAN add 10. I can't remember the exact command, but that's basically what we're doing. The add part is very important on the Nexus switches at least. So, and that's how we've done things for like 20 years, some variation of that. We haven't had hypervisors in common use for 20 years, but we've had most of the other components in use. So where does it come with orchestration? Where does that come with controller to controller? Well, so doing it by hand is certainly still on the table, and a lot of shops will still do it that way, and there's nothing inherently wrong with that. But we have the network world, and we have the hypervisor world, or the virtual world, or the compute world. So I've got my hypervisors here, and on them they have their vSwitches. We use purple for that. And then I'm going to add my port groups. I'm not going to draw the VMs. You know that VMs need connectivity. So they need connectivity up through their VMNICs. I'm just going to draw one for brevity's sake. Now the question is, I need a VLAN. I need a resource. How do I automate this? Can I automate this? And the answer is yes. But I'm going to need, so I already have a controller on the VMware side. So that's vCenter there. So vCenter is going to be our controller. And on the networking side, if I don't have a controller, then I've got a bit of a problem. So I've got my switches here. I'm going to do a leaf spine. Pretend that's all connected the right way. And I've got these connections here. Each of those port groups, I've got four port groups down there. Each of those port groups is going to require that I have a VLAN for them. So I need a VLAN. Can I automate the retrieval of that VLAN? Well, if I'm just configuring each of these devices one by one, then vCenter is going to need to know about all of these switches. So I'm going to have to write a vCenter plugin. It's going to have an inventory of my switches. It's going to have to go in each of the switch to verify that a particular VLAN is not used, or create an inventory of what VLANs are or not used. And then it's going to go into the specific switches here and add VLANs 10, 20, 30, and 40. At this point, vCenter is now my network controller as well, because it knows more about my network than any of the individual switches do. It becomes a central point of truth. It's probably not the best place for that. So why don't we, that's what several companies, several different vendors have done. Let's just go ahead and have a network controller. Examples of this are Big Switch or Cisco ACI, or there's other examples as well. And so vCenter just talks to the network controller. That's all that has to happen. So vCenter goes to the network controller, hey, I have 4 port groups, I need 4 VLANs. The network controller goes, okay, I know the state of the network, I know where everything is, and here's 4 VLANs for you, so it returns the 4 VLANs. And then it goes into the appropriate devices, configures the VLANs and the interfaces and so forth. And then we have things like LLDP that are communicating where these clients are, and some other stuff can go on. So there's in-band communication, there's out-of-band, there's northbound, southbound communication that's going on, and that's why we need a network controller. Or we need a network controller if we want to get to this level of orchestration. Not every organization is ready for this level of orchestration yet, but most of them are probably going to get there at some point. So that's why we need a network controller, and that is software-defined networking. So this is an SDN product up here. And you can make an argument saying that vCenter is an SDN product because it also controls its own switches with its distributed virtual switch. So you'd have one place that you configure the switch, and it goes and pushes that configuration on down to the virtual switches on each of the hypervisors. So vCenter is, it is a software-defined networking product. Let's go back to our list here. It has a controller, yep. It has an API, sure does. It has network virtualization, sure does. It doesn't use it uses VLAN instead of VXLAN, but still, virtual LAN. So it is absolutely 100% a software-defined networking controller. So we need this to work if we need to want to get to that level of automation. And data center networking, I just use that as an example because I tend to do stuff in the data center. I teach data center technologies for the most part. But we've had it in other parts of even enterprise IT, for example, in Wi-Fi. So a long time ago, we realized that going into 20, 30, 100,000 different Wi-Fi access points and configuring them, going config T and typing in this stuff, wasn't going to be scalable or implementable or manageable or anything. So early on, all of the vendors decided to go to controller-based architectures. So all the APs get their images, their configurations, etc. from the controllers. So we've done that for Wi-Fi for a long time, and we're never going back. It's not going to get to the point where we go into each of these individual devices. If we want to do any kind of scaling of Wi-Fi, I mean, my Wi-Fi system at home, I configure it by hand, but most enterprises are not going to do that for 100, 200, 2,000 different access points. So we've had it in Wi-Fi. And you can consider Wi-Fi controllers, Wi-Fi solutions, wireless solutions, you can consider them SDN because they're software defined. They have APIs, they have controllers, and they have some sort of, the virtualization part might be a little bit of a stretch, but they do certain segments and they allow for things being torn up and torn down. In summation, I would say that yes, today in 2020, that in the middle of 2020, May 2020, COVID times, SDN is still a thing. It has been a thing, it is a thing, it is still a thing. Is it necessary? Couldn't remember how many C's are in necessary. Not a very good speller. There's no spell check when you write things down. Like anything else in networking, it depends. It depends. I think someone's probably got that trademarked. It all depends. I would say if you're doing some sort of data center networking, at least to be familiar with the concepts of software-defined networking. It probably will be necessary in the future, assuming the data center gets to the enterprise data center, the data center that you run versus Amazon or Google or whoever. Assuming that's in the future, then that will probably become more and more necessary. So I hope you found this useful. I hope you found this valuable. Please let me know if you have any thoughts in the comments section below. And thank you for watching. Again, my name is Tony Bourke.